join us will join us eventually. But let's not waste time. Okay, so I believe you can see my screen over here. This question came from a 2023 paper, so I can just make a note of that here. April 2023. And let's quickly solve this one. I think it's 4 marks. Okay, so we can do this together. Let's quickly do this. All right, so let's look at our numerator. So cosec 360 minus x, will that be a positive or negative cosec? Colleagues? Fourth quadrant. And cosec is linked to sine, I believe, right? Is it a positive or negative?
It's a negative, sir.
It's negative.
Yeah. So we have negative cosec. Perfect. We have a cot negative x, right? And as I said to you, negative angles being measured that way down. So it's placed in the fourth quadrant. And cot is linked to tan. Is it positive or negative?
It's negative.
Negative, that's correct. So that's a negative cot x. We've got cos 90 minus x. I think at this point, I didn't obviously explain, but we all aware that cos 90 minus x is equal to sine x. Are we happy with this? Or should I unpack that co-ratio? But obviously it'll be positive, but it's also equal to sine. Are you familiar with this?
Yes.
Okay.
Yes, sir.
Okay. If you're not familiar, then I can always explain. Sine x. I'm just normally when I do the cos 90 minus x, it's typically the sine one. Doesn't always have to be, but yeah. Sec 360 plus x. So plus x obviously over here. Is that a positive or negative? Sec. That's linked to cos.
Positive.
Positive.
That's correct.
Positive.
Yep. Then we can put in there sec x. Our sine 180 minus x. What is that one?
That's
Positive.
positive.
That is correct. And then we have tan 90 minus x. Obviously, we just have to square him once we're done. What's tan 90 minus x? What quadrant is that?
Positive.
First one.
correct.
Positive.
Yeah, so that's just going to be tan squared x. Perfect. So this is what we have. And it seems like we're stuck, but now this is where you have to expand all the individual ratios now. So for instance, over here,
Sir,
we can, yes.
can we do that then? Squared 90 minus x. Can we make it like cot x?
But oh, like you mean like a co-ratio type of thing?
Yes.
I'm not sure if that is possible because it doesn't work. I'm not sure unless you have some math which I'm unaware of.
No, I don't.
Okay, no. So this co-ratio thing works particularly for these two, man. Yeah, it's not a like sec and cosec. It's not like that. Yeah, so it's just like that.
Yeah. So in the book, there's an example with a tangent squared is changed to cotangent squared.
No,
So-
man. It can't be just so simple, man. Let me have a look. Unless you can show me exactly what you mean. It's the only link between them directly is the Pythagorean identities, man. Not just a straight 90 minus x. I will just look. I'm pretty sure. Yeah. Yeah, but if you find something, you just always just let me know. Okay, anyway, let's, yeah, no, I don't know. Show me. Just if we can find something, then I will explain, I will see. Anyway.
So is example 3.90,
Okay, I'm pretty close there.
the first one.
3.19. I'm there.
Yeah. It's,
Yeah. Oh, I see there. I see. 10, 90 minus theta equals cot, eh? Interesting.
Yeah, so when the lady asked it, I was also curious about what's happening there. Why is it different?
Is it explained in the book somewhere before? Let me just check, man. Because so Dalmori could be right. I'm just looking at the score ratios quickly. Let's see if I can find some score ratios here. Let me see some score ratios here. I see it there, but I mean, like, where's the explanation? You know what I mean? But I know how to probably figure it out, but I'm just I want to be sure. Okay, I see them here. I do see them. Yes. There are some correlations here. Okay. It is possible. Yes, you can do that. Yes, it's right. Yeah, you can definitely do that. I'll just pull up the table which I'm looking at. And it looks like this. Okay, it's a good question. So we also have correlations over here, guys. Not only for sine and cos, and we can do that for tan. Thanks, Dalmari. And you could also represent the tan 90 minus x actually as, oh, let me just erase the part that I want. You could also have this as now cot. Was it cot, right? Cot squared.
Yes.
Cot squared x.
Yeah. So there we have the co-ratios, sine and cos, meaning, yeah, and then cos and sine, tan and cotan and tan, obviously, sec and cosec, and then cosec and sec. And they all work basically the same way. I think it's also sine 90 minus x equals cos, if I'm right. Huh?
Yeah.
So yeah, those are the correlation things that you guys are aware of. Thank you for that. And obviously, makes sense that obviously the other one should also have something similar. Okay. I'm just finding it. What was I thinking? Okay, fine. No problems. Okay, so yeah, we have that. We can do that. So if you need to expand upon these, that's going to be 1 over sine. Yes, we can make him negative. This will be cos over sine, right?
Yes.
Fine. Okay. Obviously, we could have actually sorted it out. You know, we could have even reduced here. You see what I'm saying to you? This one and that one. Yeah. So, but it's fine like this. Yeah, we have sine x divided by 1. And you can see I'm being really deliberate. I'm separating the numerator and denominator so we can multiply the tops and the bottoms nicely. Over here we have 1 over cos. Over here we have sine x over 1. And here we have, of course, cos squared x divided by sine squared x. And then, with my rule again, we're going to multiply all the numerators and all the denominators on the numerator section, all that numerators and that denominators. So on top here, you're going to have, that's a negative, you will have a positive cos x, am I right? Cos x sine x, sorry. Right, that is 1 times negative cos x times sine. The bottom, we're going to have sine squared x, like that.
Yes.
And then we're going to do exactly the same at the bottom. We're going to have sine x times cos squared x in this case, right? Yeah, that's that. Then we times in the bottom as well. And that's going to be cos x times the 1 times sine squared x. Is everyone happy with that?
Yes, sir.
Okay. Anyone else? We're all on the same page so far? All
Yes,
right,
sir.
okay.
Yes.
Okay, great. So then what we do, we're just gonna have to do our flip. Our what's an inverse reciprocal multiplication, whatever they call it again. So it's cos x sine x divided by sine squared x. So obviously if you have like 1 over 2 divided by 1 over 5, if you want to find an answer, all you have to do is flip denominator over like this. I'm sure you guys are aware of that. So I'm doing exactly the same mathematical procedure over here. So multiply, obviously flipping this one. Here we have cos x sine squared x. Divide that by, is it the same thing? No, no, no. One is sine squared. Okay, the other one is
Yeah.
cos squared. Yeah, okay. Okay, perfect. And then I think with this one, we can just quickly see what we can divide out. So I think we can divide out this guy and that guy. Obviously, when we multiply them together, we've got a cos and a cos here, right? Am I right? That goes.
Yes.
Then we have
There's another
this
cos.
cos, that
One,
this one. Yes?
one of that goes to the other goes, yeah.
Yeah. And then
Yes.
you're basically left with sine and what? Sine
Cos.
x on top, and then a cos at the
Cos.
bottom. And I believe the answer should come out to
10.
I don't know if that is correct, but I mean, you should have a look. I mean, that unless we've missed something, but it seems mathematically correct to me. Yeah. So, yeah, I hope everyone got that. Obviously, we could have reduced this a lot quicker, even from this step over here. You see over here, what we could have done as well, we could have eliminated the signs here. You see what I'm saying to you?
Oh,
We could have eliminated a cot here. You know what you're with me? You know, so we could have made it a lot. You could have simplified it a lot earlier, but I'm just being very particular. So any questions on this one? I'm hoping the answer's right. I mean, doesn't seem like we did anything wrong. But yeah, just have a look. Any questions before we move? Yes or no?
yes.
Yes, what's the question?
No.
Oh, yes, as in we can move on. Okay, someone silently. Oh, can we move on, guys? Damari, Lori, Heinrich, Liteta, Ashwin.
So the question just says simplify, it doesn't say left hand side to be equal to right hand side.
No. This is just a simplified type question. Yeah.
Okay.
Yeah. This one, I'll just carry on with what we did yesterday, man. Just to get people this type of stuff. Because we get the two types of questions. The one where we have to, left hand side, right hand side, and this one is a simplified type. Because I wasn't sure if people are aware of these angles and all that stuff. So I thought I'll just redo this one or this type of problem. But now anyway, we're gonna move on to equations now. Is that fine?
Fine, sir.
Yeah.
Yes,
Okay, and
sir.
this will be the remainder of the session. So I'm just going to start with a very basic concept, and I'm going to immediately go into the ones in the book. So just give me a few seconds here. Okay, cool. Here we go. So we're gonna do a few of these ones. So be ready. Let me just choose this one. So it's worth paying attention while I'm solving this one, because it's you understand what I mean when I'm saying this. I know a lot of confusion comes with these problems. Okay. The equation. Yeah. Okay. So we're going to start solving equations. So just so to let you know, this particular one in front of you is not what you get. The ones you get, or you will see them now. The ones you typically get is a mixture of ratios together. But what is important here, as I'm solving, is the understanding of this thing called a reference angle and the quadrants. And you'll see what I mean. So what we're required to do in this particular problem is to solve this equation. Keyword equation. Now I want you to think about this. Is my red pen here? It's the equation. So we have 5 sine theta plus 3 equals 0. We need to find the values of theta from 0 to 360. Perfect. Because in the equation, it's like anything else, we need to solve for some variable. What we do, we carry over the 3, which is fine with everyone. I'm sure you understand that maths. And obviously you have to divide both sides by 5, right? And we have 3 over 5. But as you carry the 3, that should have become negative. Is that fine with everyone?
Yes, sir.
Yes, sir.
Now, first step here. So when you see a negative answer here, right? If you have a negative value, I want you to ignore this first. The first thing I want you to do is I want you to find sine theta 3 over 5. And the angle you're going to find here, that's going to be this reference angle which I'm talking about, right? Which obviously will be so sine -1 3 over 5. So we can ignore the sign and just look at the absolute value, and we're going to find this. I believe everyone can find this on the calculator. Is that correct?
Yes, sir.
Okay,
So-
perfect. Let me just go to my calculator and get that value. If you don't know how to find on the calculator, please let me know, so I can obviously show you. Yeah, I just want to cancel this here. Hey, what's going on? Okay. That's going to be shift. What is it? Again, 3 over 5. And you should get 36.87. That's fine. Okay. 36.87 degrees. So that's just the reference angle I'm talking about. Is everyone happy with this? I believe we all can do that, right?
Yes, sir.
Is that fine? Or am I look on the calculators like this? I just want to put a screenshot for you so you can see. So obviously I'm using the second, the inverse function 3 over 5, and then you obviously can find that. I believe everyone is familiar with how to get that. But now, once you have an angle, this is where you have to look at the sine. So now the sine is telling you in which quadrants this is all going to be the values you are looking for between that ranges. So in this case, if you want to look where sine is negative, and sine is negative over here and over here, as you know. Is that clear to everyone?
Yes, sir.
Yes, perfect. So again, you don't put -3 over 5 in the calculator. You don't do that. You can do that, but just don't do it. You do 3 over 5, you get an angle. So this angle now will tell you the two values of sine we're going to get. Or it's the two values. So let's say theta 1. So we know our first value must be in this quadrant, which is 180 plus the reference angle, right? And our second value, do we have a second value? Or the next quadrant is 360 minus, the reference angle. Okay. So I don't know if everyone's aware of this. You know what I'm saying to you? It's because I'm just curious to see if you guys know. So we do the first one, this should be around 216.87 degrees. And then the second one will be what is it? 3 to 3.13, I think, 3 to 3.13 degrees. Is everyone happy with this?
So far, so good for me.
Okay,
Sure.
the Boyo, Dalman, good, right? Now my question is, why do we have two values?
I'm good, sir.
Okay, why do we have two values? Can anyone answer my
Because-
question?
Theta is supposed to be between 0 and 360.
Yes, that's fine. That's one reason, but I'm looking for another reason. Do you have another reason for me? Does anyone have a reason for me? Now, let me show you why. It's back to what I told you even yesterday. So you have a limit. However, this is the reason why. Because sine is a continuous graph. Look here. So 3 over 5 is what? 0.6, right? Am I right? 3 over 5, 0.6. What is it? Yeah. So 3 over 5, negative 0.6, right? Is equal to 3. And it's the same thing. Are we fine with this? That on a sine graph repeats twice. You understand what I'm saying to you? And that's why there is two values. So if you had to have positive 0.6, it probably would have been here somewhere and here somewhere. Are you guys with me?
Yes, sir.
So that two
Okay.
values, that's why we have two values, because it's repeating that way. And obviously, if we extend the period, it might be more values. Another way to verify that you're correct, colleagues. So because we're dealing with something called an equation, remember I told you this is an equation? All you have to do is this. Let's quickly see if it's possible. You want to resubstitute your answers into this to check if you're going to get 0. So let me just quickly go through again. It's 5 plus, what was it again? 5 sine theta of minus 3 equals 0. So all we're simply doing now, we're taking this goal, putting in here, and that goal, substituting in here. Okay. So I'll quickly do that. So that's how you can actually know whether you're always right or not, just by the way. So I'm gonna just share the calculator quickly, then you're gonna see what I mean. Okay. I believe you can see it. I think you guys can see it now. So the first one was, I'm just looking at this, yeah. 5, what's it? Sine 216, no? 187 minus 3.
Plus 3, sir.
Plus.
Plus 3.
It's plus
Plus
3.
3.
Okay. Yeah, it was negative on the other side, yeah. Okay. And you get a very small answer. Okay, it's hard to tell, but yeah, it's good enough. And then if you put in the other one, which will be, what's it? 3 to 3.13, you should get roughly the same. Obviously, that's 0.00000. It's exactly not on the 0, but yeah. But at least these two answers should be the same. So that is one way of identifying that you're right. Okay. Cool. So let's move on to the men and the woman stuff now. Let's see. But the key point here is, like I said to you, the reference angle, the sign is just there to tell you whether which quadrant you are in, and that will obviously give you two values. And that's what's key over here. So let's go back to the N4 book, and then we can start solving. All right, so I'm just going to find some stuff I'm going to start with example 2. These ones here. Yeah, okay. Example 3.23. I'm not sure if you guys know how to do it, just tell me. So we can obviously go into more, challenging stuff if that is required. So I'm just assuming people still getting the basics in order. There we go. So these are the equations I'm talking about. You guys familiar with the stuff? Julio, Richard, Dalmarie, Ashwin. Yes.
Yes, we will give it a try. Yes, thanks.
Okay, let's look. So I'll do the first one. Maybe you can try the second one, and you can try the third one. So number 1. So this one, it's all the same stuff. Just now I'm trying to make it a bit more fancy. Add some spice. And all this basically is, with these problems, right? I want to be clear. You always want to make sure that you are, what's the word I'm looking for? You ideally want to work with one ratio. That's what's happening here. But what can be tricky is that you obviously want to get a wide range of values here. And but I mean, because we have two trigger ratios and therefore, yeah, you'll see what I mean. So what I would have done first is obviously divide all the 10s out, right? So if I divide 10 by 10 on both sides, I'm left with this. Is it fine with everyone?
Yes.
Okay.
Yes, sir.
And I follow the same procedures before. Cos x, that'll be 1/3. So first thing I do, I'll get my reference angle. And that obviously will be cos second function 1/3. Let me just work him out quickly. See, you should get 70.55. That's fine. Okay. 55 degrees. Okay. And then obviously, next question to ask yourself, sign is cos positive? It's positive, therefore it's positive over here and over there, right? And so you're gonna have to say θ1 will be the first value will be 70.55. You guys agree with me? Because it's that value there. You guys with me? Then our second value obviously will be the 360 minus our reference angle. And that will be the 360 minus 70.55, which will give us, what's that? Around 289, is it? Just check again. Yeah, 360 minus 70.55, 29.45 degrees. Are we all happy with this? Still more to say here, but could you all understand this?
Yeah, this is clear. This is quite clear. So.
Okay, great. But now the issue is, like I said to you, because you have two ratios, man. Unfortunately, you might have more answers for this particular equation. And so what it means is that yeah, we already have two answers, but there might be some more answers. And what I mean by that is you take the same equation and you do it like this. Oh, I want to do black instead. You say 3, make this big here, 3 cos x tan x, and I carry over that tan x, make that equal to 0. And then what I do here, I can take tan x as a common factor. And that's going to be 3 cos x minus 1 equals 0. And can you see over here, we still have the same setup here. You see there, that one there. So one equation will be tan x equal to 0. Can you see that?
Yes.
And the other one is equal to 3 cos x minus 1 equal to 0. So this is already kind of done on this side over here. However, here we have our tan x equal to 0 over here. And now we obviously have to now sort this guy out. And if you do second function of 0 for tan, what do we get for that one? Tan 45 is 1, eh? Let me just check on my calculator here. Yeah, not tan 90, the asymptote one. Tan 0 is 0, right?
Yeah.
And then, so the reference angle here is 0. And because it's 0, or it's positive, whatever, the other one is going to be the 180 plus. And so therefore, we can say θ1 is a reference angle, and then θ2 is also going to be equal to 180 plus the reference angle, which is essentially 180 degrees as well. So yeah, so that's quite interesting. Now, with a problem like this, we have two ratios. You actually can get two other values. So all the values possible for these equations are the four of them. I could have called this theta 3 and theta 4. But yeah, just letting you know. I would have probably done this one over here and call it a day. But let's see. So they are that does kind of exist. So let's do the next one. Okay. So let's try this one together. And your number 3 you guys can do. Where's it one? Okay, 2 cosec. So this one was a bit fairly easy, I think. Here we have cosec over here. And obviously we all know that cosec in this case is 1 over sine. Am I right?
Yes.
Yes, sir.
Then what do we do now? We should multiply the sine on that side over here. So we times both sides by sine basically. So we're gonna have 2 sine squared and that'll be equal to 1. Are you all happy with that?
Yes.
Perfect. Then we're gonna have sine squared equals a half, I believe. Right?
Yes.
And then obviously to get rid of the half, we must root him. So then we have sine x equals root 1 over 2. Right? That seems like a familiar number to me. Yeah, root of. Yes, which is the same as 1 over root 2. Something like that. Yeah. And then basically we carry on the same procedure. So the first step again, we find the reference angle. All right. So we just say, just give me a second quickly. Just find the reference angle for me.
Is it 45?
Did you get 45?
Yep, should be 45. 1 over root 2, yeah. 45 degrees. Okay. And like I said to you, it's positive. Obviously you can see it's positive, so therefore we know sine is positive here and here. Oops. And so our first angle at this point is 45 degrees. Our second angle is 180 minus 45, which basically be 135 degrees. I believe that's the correct answer. But I'm missing something. And what am I missing? Who can tell me? Back over here. This part here. Let me just remind you guys, if I have x squared equals 4, right? Are we happy here? Can you see this? Colleagues?
Yes, sir.
Yeah.
Yes, sir.
Yeah, and I have to obviously root this here, yeah? Am I right? And the answer is x here, am I right? And if I root of 4, what are my two values? Plus minus 2.
2.
2.
Exactly. So we must also have here plus minus. Are you with
Minus.
me? Yeah.
45.
Because we're squaring. It's like a parabola. We have two x-intercepts. Same story over here. So therefore, our other side will be the same, but it will be now sine x equals negative 1 over, or you can just simply write 1 over root 2. Same thing. So reference angle should still be the same, 45 degrees, am I right? That doesn't change, but now our quadrants are different. So it's negative over here and negative over there. Is everyone happy with this? If not, please say something. And can I get that theta 3 and theta 4, please? Should be easy to do. I mean, you can work it out in your brain, really. So Van is not good for the brain, eh? It's not good for maths. Just letting you know. Just like with just like with Clippies.
Isn't it 225 and 315?
2 to 5,
Exactly.
yeah. Mm.
Yeah, there we go. And
So-
what's it? 315, eh? Yeah. Done. That's it. Nothing more. So there were 4 values. But the main part here is that if you have a square, be cognizant of the fact that it will provide you 2 values. You know what I mean? Not just 1. Yeah, that's the main point of this one.
So are we now saying theta or must we say x?
How's theta's fine, x, whatever. You know what I mean? Just forgive me. X1, you can do x2. Yeah, x3.
So are they going to mark me wrong if I say theta?
No, they won't mark you wrong, man. No.
As long
It's
as the concept.
just language, you know? I mean,
Okay.
if we could have created our own symbols if we wanted, you know that. You know, we could have made our own symbols. I'm making symbols up now, you know. Let's say this was the Cape Malay or colored symbols, you know what I'm saying to you. This could have been this could have been symbols, but it represents the same thing. You know what I'm saying? This could have been a language, and I'm creating stuff just, and we could have said sign of whatever this was, you know. It's just a symbol. It means the same thing. Yeah. Okay, cool. So I want you guys to try the other one. I'm only going to give you 3 minutes for this one. And then we're going to move on to some more. Okay, cool. Try this one. Obviously, we should all know what sine 2x is by now. Huh?
Yes, sir.
Okay, all the best. Are you guys winning?
Okay, so I'm done, yeah. I think I'm okay with this one.
I'm done.
All right, give me the answers.
For the first angle is 60 and the other one is 120. It was first and second quadrant.
I see 60. Sure. 20. Apparently, here, there's 5 answers, right? And remember, you have 2 ratios. How many, what answers do you have?
120 and 300.
Are we doing the same problem? Am I looking at the same thing? I'm looking at the book here.
I got 60 and 300.
Yeah,
Yeah.
Quarter one. Okay.
there's 60 and 300 for sure. So, and did you guys look at maybe, you know, I guess you guys divided both by sign, right?
Yes.
Yeah.
Yes, sir.
Yeah, but here's this thing what I was telling you now, which is a bit, I'm not sure they'll mark you wrong, but let me come into it. So obviously the first approach is this. Obviously we both eliminate both signs on either side, am I right? Divide out and left with this. Is that correct? We have cos x equals 1 over 2. Our reference angle here should be, I believe, 60, right?
Yes.
Now first, which is positive, first one will be 60, the second one will be 300. Okay. But remember, because there's 2 ratios here, again, like the previous one, and I think there's a pattern you should be picking up now. If you take 2 sine x, let's make this big again, cos x, and you carry over the sine x, you make that equal to 0. And then you take out, I guess, sine x is a common, you can take out sine x as a common factor, right? Which that'll be 2 cos x, right? This would be minus 1. Can you see that now we have this one, which is here? Can you guys see that? Then we also have a sine x
Yes.
equals 0. Are you guys with me?
Yes, sir.
So then we
Yes,
have
sir.
more values on this over here, on the sine x equals 0. Like I said, just be aware when there's 2 different types, you could have more values. So I'm not sure they'll give you all the marks or not. You know, I'm not sure. I mean, I don't mark, I don't assess. I should apply
Okay.
to assess one day. But anyway, I'm just making you aware. So obviously from 0, sine 0, it'll be 0, 180, and I think 360. Yeah, so we have more values. Again, this is all coming from the text. Okay, let's do some more. So this, I'll do the first one, and I want you to do the second one. Yeah, great. And this is Richard's old favorite with quadratics. You'll see now how to come up. Okay, so here we are. Now these ones are the prominent ones which I've seen in the past papers. And yeah, again here we're gonna have. I think these are a bit better than the previous ones in a way. But let me try number 1. So number 1, we have 3 cos squared x equals 1 plus 5 sine x. So these ones, what you actually want to do is try to make the ratios all the same. Okay? So if I see a cos squared x, if you think of the old granddaddy, you should know by now that that's going to be 1 minus sine squared x. Right? That's 1 plus 5 sine x. And you can't date someone who doesn't know that. You need to reconsider the relationship. It's common knowledge. So that's
Okay.
3. That's 3 minus 3 sine squared x. 1 plus 5 sine x. Okay, that's fine. Obviously, again, in my mind, when I see x squared, I'm always looking for a constant You know what I mean? Or they a constant or the x and with the c. I look for x squared or sine x. You know what I mean? A sine x, another variable, and some constant. Then I know already I'm talking quadratic. So what I do now, I rearrange my formula in the standard quadratic form. So I'll bring everything to that side over here, to the right-hand side, right? So I have 3 sine squared x plus 5 sine x. And then obviously I have 1, is it? 1 minus 3, right? It's going to be negative
Plus
2.
2.
Yeah, okay. So there you go. There's a quadratic for you. Now, you need to solve this quadratic, right? So to make it a bit more neater, we could even say let k equals sine x, right? That's fine. Then we can have 3k squared, just to make it another variable. You could have kept sine actually, right? 5k minus 2. You guys with me there? Just to make it a bit more neater, right? Then over here, you can use whatever you want. You can use your quadratic formula. You can use completing the square. Or you can use factorization. Okay? But we experienced mathematicians, so we'll use factorization. You know, there's going to be a 3 and a 1 over here. Obviously, it's going to be k. We know that we must have a 2 as well, right? A 2 and a 1. So where would the 2 and the 1 be? So I know that there must be a 2 here to give me I put it like this, was 3 times k. They must give me a 6k. 3k times 2 is a 6k. But that must be positive, and the other k must be negative, right? Which is yes. I think that must become negative to subtract the negative k, and I must make that positive. I think that's correct. If my brain's working right. You guys with me?
Yes, sir.
Yeah. So, like I said, you can always go to quadratic. So some of you guys, Jesus, you guys use the quadratic. Obviously, then you have to just have, you have 2 things. You have 3k minus 1 equals 0, or k equals, or k plus 2 equals 0. Obviously, we've declared that k equals sine x. So we have 3 sine x minus 1, am I right? Equals 0. Or we have sine x, what is this? Plus 2. Luckily for us, sine operates in limits of 1, less than, greater than, and like that. So we know that sine cannot be equal to, you know what I'm saying to you? To 2. So we don't have to worry about that one. Is everyone happy with that one? Should be undefined.
Yes.
Yeah. Okay. Then over here we come up to the same procedure as before. So not so. Where we're going to say sine by c equals to 1 over 3. We carry over the 1 and then we divide by 3. Where is sine positive? Sine is positive here. And sine is positive there, right? And then we solve. And then your x should be sine inverse 1 over 3. Back in the day, there needs to be tables for these values. And then your answer should be 19.451 degrees. Your reference angle, and obviously your x1 will be equal to your reference angle. And then your x2 will be equal to 180 minus 19.451. And that should be basically 20 less. So it's like 160. Yeah. 160 point something. 549. Okay. So everyone happy with this one? You're going to do the next one. Don't worry. Are we content with this one? Is there any questions? Teta, Lori, Tanukazi, Heinrich, Richard.
All good from my side.
Okay, okay.
Good, sir.
Okay, sure. Okay, so what you guys can do for me now, try this one, right? Again, the main point are to get one trig ratio in for these ones. What's happening there? Maths can give you flu, eh? Letting you know. Huh? Yeah, Maria, so you're right.
It's sinus. It's sinus, sir. It's
Oh,
windy
oh.
where.
Okay, okay. Right, anyway, so try that one. And remember what you want to do is you want to make all the ratios the same. So remember your cos, let me be kind and put it there for you, you know. Copy in and just paste in. Okay, I'll give you guys around 4 minutes for this one. Colleagues, are you winning? You guys winning?
1 minute, sir.
Okay, okay. Just found something interesting here.
Done, sir.
What answers did you get?
0 and 360.
100%. Well done. Anyone else? Hey. Anyone else?
Same, sir.
0 and 360?
And 0, yes, sir.
Perfect. Anyone else? I'll just put up the solution there and then, yeah, we can basically close off. Okay, let's see over here. All right, guys. So again, what this is what you should have done. That cos 2x should have been 2 cos squared x minus 1, right? Minus 2 plus cos. Again, you probably want to think of a quadratic over there, which does come to play. We let cos x be k, and it yields 2k squared plus k minus 3. We factorize that guy, and then eventually it's equal to 2 linear functions. You find 2k plus 3. Obviously, we cannot solve that within the limit of cos. It's 1.5 or negative 1.5. We have k minus 1, and the k is 1. Obviously, we are able to solve that quite easily. And that'll be 0, and then obviously 360 degrees over there. And that's basically it. And again, if you plug those values, the 0 in here, the 3 and the 0 and 0 in there, or the 360 and 360 in the original equation, you should basically get 0 as well in this case. Is there any questions on this one? You guys good?
Yes, sir.
Okay.
Good, sir.
Okay, guys. Okay. So guys, that's the end of the trig session. I'm going to see you on Monday for functions. Yeah. What I do recommend immediately right now, or depending or later on, go to the past papers, maybe go to 2023, 2024. Yeah, just take 2023 maybe. Choose all the questions in the trig section, you know what I mean? And then just solve them. The brain works best, you know, like you must strike when the iron is hot and you gradually taper off. So don't say, oh, no, I understand it. I will come back to this again. Just you strike him like while it's hot. You know what I'm saying to you? So do that. And again, I'm on the group. So if you have any particular problems, just let me know. I might cover another trick question on Monday. We did agree. I'll see you guys on Monday at 6, where we're going to start functions. But then I think I'll just end it with this. I was looking at some stuff I wanted to send you guys, man, or show you guys, but just as a means of where these things could be useful. But I guess in a day-to-day problem, I guess with functions I can articulate it better. But let me just see if I can find something here from another subject which I taught. Okay, this is now, it's balancing. Okay, yeah, I probably have to come back before balancing. I'll show you guys now. If you go, okay, just give me a second. So is anyone in the automotive space over here? No one.
Yes.
In what sense now,
Not.
sir?
So sorry?
In what sense now? In the
No, like
automotive space?
automotive, like working on
Yes.
cars and things
Yes,
like
sir.
that. You are.
Yes, sir.
So what do you do exactly, Ashwin? Let me see.
Currently, I am basically self-teaching myself.
Oh, okay. So, but just to give you some quick things here, man. Yeah, just to show you where a lot of the tricks can come into play, and this is one of the versions. This is under CAMS, and all the CAM stuff. Here you have all the equations telling the maximum during the return and outstroke. It's all trigonometry. You can even see here, this is the displacement of the follower, if you know how CAM looks like. And all the equations, you can see they're all somewhat end up in trig graphs. But the other one I want to show you is this, where we can all easily relate to. Anything with some kind of geometry and angle trigonometry is going to be at play. This is brakes now. I don't want to be at brakes. This is not what I'm looking for. I know exactly what I want. This after CAMS. No, it's not after CAMS. After CAMS. This is CAMS. Okay, this is balancing as well, but this is more vectors as well. If you have basically when you're rotating as well, and what mass must you put on. But this is not too hardcore trick. This is more vectors and so on. The element of centrifugal force. I think you guys do this in N6. And this is reciprocating masses in this case. So, like your pistons, making sure that's balanced out. Again, there's a few trick stuff, relations you can actually see over here. So, sorry, Luvuyo? Okay, yeah,
Yes.
you can see some derivative stuff applied, the maximum. Yeah, this is for. So this is a case where, because this is a locomotive engine, we have the distances between all the wheels and stuff. Yeah, wheel 1, wheel 2, and how do you actually balance it? That. And then the one I wanted to show you. Let me just go to the start quickly. Okay. So but automotive design is not something we do anymore. We're just an assembly line, it seems. It's gonna be under. Oh man, where is it? Yes, okay, I see it now. So 520. This one talks to the forces. Again, you can see a lot of trigonometry and angles and stuff, similar triangles. This is not. Yeah, so like here, this here is basically a piston crank, your standard piston model you know, your piston is moving, crank is turning this way, the piston is moving up and down, and all of the stuff, the relationships, you can actually work, you have formulas for everything. So you've got a formula for the distance traveled by the piston, which is X. Can you see what it looks like there?
Mhm.
You take the derivative with respect to theta, you make it equal to 0, you can actually find the maximum, right? Here's another one, you take the derivative, you take the derivative of X with respect to theta. Here's a bit of chain rule happening here, right? You get an equation for the velocity of the piston at any crank angle. They're all in terms of the crank angle. N is with the rod length and the crank radius. Again, some more derivatives. You take a derivative again. You can find the acceleration formula at any point of the crank angle as well for the givens here. So yeah, I mean, look at this. This is all differentiation and trigonometry together. And I mean, if you have these models, you can easily do that. Like this one, they want to know, for instance, where does the maximum velocity occur? So you take the derivative of this thing, and you make that equal to 0, and then obviously you have an equation. You can then solve it. And guess what? You see the tricks that we just did now over there? And we can find at 75 degrees, that's where the maximum that's where the maximum velocity will be at that particular crank angle. I don't know if you find that interesting.
Yes,
But yeah. So what I can tell you, I'll show you another one, and I'll just say something. This is now, this chapter is the main part. This is here. You can actually see all the forces are acting in a piston reciprocating type engine. This is neglecting the weight now. But it's legit. Your on the piston, it's the FP, which is obviously reduced by the gas, right? Got the normal force, got the weight of the piston. This engine obviously is horizontal, not vertical. And yeah, it's that again. Then you can actually find the torque, and the torque formula looks like this. Again, a lot of tricks here as well. Some more tricks, some more angles. One angle is obviously the crank angle. It's obviously important. There's another, and that phi. The phi is over here. The phi is over there. And then this is one problem here where you have to find. Yeah, is it not this one? Where you have to. Okay, here's a vertical engine. And what's quite interesting with this type of problems, depending on how the crank is turning, your torque will change obviously because the weight will be acting down and all of that. That's another interesting one. Here's one where you have to find this angle of inclination of the connecting rod, line of stroke, but of tricks there in the mechanics way. This one is a thermodynamic type problem incorporated into the mechanical problem, because obviously operating on Otto cycle. And if you guys know this stuff, you probably learn it. But yeah, what I want to say is, what is not being taught to a lot of us is that the maths is always present in all our systems, but people don't tend to apply the math properly. If you look at any top institution, I was at the workshop now on Thursday for Voith propellers, man. This guy was basically like selling propellers. And if you look at Voith, they make propellers for ships, but a lot of these top companies, I mean, I don't know how much money they spend on research and development in terms of maths. That is why they stay on the edge, because of these mathematical formulations. Obviously, they can do all the simulations and all these things. And I just think we lack that here. It was every company you come to, I don't know, depending on you guys, your experience, like math is really put in the background where what an engineer basically does is what I'm showing you. Legit this, using all the equations to make decisions, and so we can make quicker decisions, so we can make money. So yeah, I just thought I'll show you guys. Obviously, just some more trigonometry stuff, and the understanding of it's obviously important, you know. And you can see there's another formula here with more trigonometry. Well, then, guys, thank you for the day. I just thought I'll mention that. Yeah, I know with you guys, sometimes you guys don't actually get to see these things, but it's not that people are more clever. I don't believe in that. It's just that people are exposed to different things, and therefore they're aware of different things. And so always try to find that line. The difference between you and the next guy is always your mathematical and science ability. I always tell people, like, the reason why we have the maths and the science, it's for decision making and understanding how variables work together. That's what it's about. A lawyer consults law to make decisions. We consult maths and science to make our decisions. That's my philosophy on how this works. But anyway, guys, cheers, eh? I thought I'll just mention that there, show you this. Okay, see you on Monday.
Quite interesting, sir. Thank you, sir.
Okay, no problems. Cheers, Richard, man. Yeah.
Okay, then.
Okay, thank you, sir.
Cheers, guys.
Thank you, sir.